Okay, good evening everyone. Am I audible?
Yes, ma'am.
Okay, thank you. So, good evening everyone once again. And welcome to our discussion for um oops, what happened? The design for drainage channel. So, this is going to be the last set of topics that we are going to tackle prior to the midterm exam. So, the midterm exam is going to happen, I think, most likely next week, no? Yeah, next week, November 4. But I still have to confirm this one with Sia. Okay, so the design for the niche channels is composed of, I think, three different topics. We have the best hydraulic section. The second one would be the shear stress. And the third one is the freeboard. And I think it would be a little too long if we are going to discuss the three. So for this evening, we are only going to tackle the best hydraulic section. Okay. So kaning topic nga best hydraulic section, you've already had this during your hydraulics, no? So this is one of the major topics in hydraulics. So I believe you have already a stock knowledge, no, regarding this one. So for this evening, this discussion will only serve as your review, no? It would be easier for you to grasp or to to absorb the discussion because you are already familiar with the best hydraulic section. Okay, so constructed open channels frequently serve as drainage ways in stormwater management systems. So, a common feature of drainage channels is that they are usually dry when there is no surface runoff and are designed to accommodate the peak runoff rate from a desired storm. So, drainage channels are commonly found alongside roadways and therefore closely linked to transportation infrastructure. So constructed drainage channels are designed to be either unlined or lined. So the common characteristic daw of drainage channel is that they are usually they are daw usually they are usually dry. Okay? So as we have noticed, kana bitong canal or that's a channel at both ends of the roadway, no? So bantay ta nga if mag-agi kita sa dalan and then walay ulan, usually wala gid na siya tubig nga nagapundo, no? Nga or na-retain dadto sa channel because that is how drainage channels work. Dili siya parehas sa kanal, no? Nga naay tubig permente. Okay, so ang kaning drainage channel is that dry siya, meaning walay tubig daan dayon ayaw pa rin siya ma-function if maabot na nato ang peak run of rate, meaning mag-ulan siya kusog, no? So ang channels, it can either be unlined or lined. Okay, so let us define each of these. So unlined channel, which are sometimes called earthen channels, are simply excavated channels in the ground through which water flows. Okay. On the other hand, lined channel are excavated channels in which various material linings are incorporated. Okay. So for the unlined channel, no, this is just an earthen channel. Meaning to say, kanang kinalot ragod sa kilid na yuta lang siya. Wala siya gibutangan og concrete, wala siya gibutangan og riprap, no? Just pure earth. Kaya wala siya lining, wala siya cover nga pwede maagian sa tubig. Meaning to say, for unlined channel, ang agianan sa tubig is plainly, ano lang siya, plainly yuta. Okay? So, in opposite, the line channel has a lining, no? Aside from the excavated earth, na gibutangan din siya either concrete, no, or riprap. Okay. And when we talk about lining materials for our lined channel, okay, na it is further classified into two. We have the rigid linings and the flexible linings. Okay, so for the rigid linings, mao ni siya katong concrete, stone masonry, soil cement, grouted riprap, or precast interlocking blocks. Okay, so for the flexible linings, mao ni sila ang riprap, katong gravel lang, or tanuman lang siya, mats, no? Or any combination of these materials. So therefore, rigid linings are called rigid because they tend to crack when deflected, and flexible linings are called flexible because they are able to conform to the changes in the channel shape while maintaining the overall integrity of the channel lining. Okay. So, channels with rigid linings are sometimes called rigid boundary channels because when you have a rigid lining such as concrete for your channel, so bisan pag unsa ka ang tubig, no, unsa ka kusog ang tubig nga moagi sa imong channel, ang iyang cross section ana or iyang shape, iyang itsura, iyang kadak-on will always be the same. Okay? Rigid yung boundary. Dili gyud na siya madako. On the other hand, if your lining is flexible such as pailan lang nimo siya bato or batangan nimo siya mga tanom-tanom, flexible yung boundary ana. Meaning to say, naay tendency nga modako ang section sa imuhang channel. Okay? So, channels with rigid linings are preferred for in a variety of cases. So, based in the previous observation and investigations, mas preferred ang channels with rigid lining compared to channels with flexible lining. So these are the reasons. Um, Transport water at high velocities to reduce construction and excavation cost. Since if you are going to have a rigid lining, the capacity of your channel will always be the same. Okay? And then, mas kusgan po siya if rigid lining imong gamiton. Okay, dako yang resistance to water pressure. And also, it is to decrease seepage loss because the lining of the channel now becomes impermeable compared sa flexible lining nga pwede mo sunop ang tubig. Okay. Also, it is to decrease operation and maintenance cost and to ensure the stability of the channel section. Okay. So the basic principle in the design for drainage channel system is, so when designed for storm water management, the design flow rate to be accommodated by the channel is typically the flow rate or the peak flow rate from a runoff event with a specified return period. So the objective in designing a drainage channel is to identify its shape, okay, dimensions, and the lining material that will safely accommodate the design flow rate at a reasonable cost while preventing the erosion of the material on the channel boundary. Okay, so meaning to say, if we are going to design drainage system, mo ni siyang tulo ang ato ang i-try og identify the shape, dimension, and the lining. Okay. So, in relation to that, let us have the best hydraulic section. Now, if I may ask you, have you heard this phrase, best hydraulic section? Have you heard this one? Nakarinig ba mo?
Kuan ma'am, kanang most efficient section.
Okay, so that's very good. So it is the most efficient section. Okay. So why do you think it is called the most efficient section?
Kuan man ma'am, kaning gamay ra yang perimeter but dako ang area.
Okay, so that's very good. Okay. So mo optimize, no? Ang area ay mas dako ang area ang pasabot or mas dako ang perimeter?
Mas dako ang area ma'am.
Okay, that's right. Mas dako ang area. So kung mas dako ang area, mas dako ang volume sa water nga iyahang ma-hold. Okay? So that's why it is called the most efficient section. Okay, so aside from that, okay, so the best hydraulic section is also known as the most economic or the most efficient section. So this can be determined by requiring that the flow area of the channel be minimized while maintaining the hydraulic capacity. So if we are going to compute for the most economic section, we are going to use the equation by Mannings. Okay? Okay. So since, as mentioned kaganihan, it is the most efficient section, as much as it is an efficient section, it is also um the most economic section because there are different shapes, no, of the channel, right? So who can give me one shape of a channel? One lang.
Trapezoidal, ma'am.
Trapezoidal. Okay, very good. So our channel can either be trapezoidal, triangular, semicircle, or the rectangular. Okay. So between these four shapes now, you have to identify asa kaya ang pinaka-best na choice. Okay? And your choice in choosing the most economic section will not only be limited to the aesthetic properties, no. Of course, you have to um, consider the factors like the construction cost, the excavation cost, the practicability, the constructionability, no, and the efficiency, no, unsa gyud ang pinaka best nga makahold ani nga peak run off rate. So through that, okay. So, for example, if we are going to use the trapezoidal, unsa iyang mga disadvantages and advantages, if ang semicircle, unsa iyang mga advantages and disadvantages, and also the triangular and the rectangular. So, actually, the most efficient section for the channel is kani mag yung semicircle, no? This is the most efficient one. However, kabantay mo nga dili siya ang very common nga type of channel. Wala man gyud sa may circle. Because although it is the theoretically, no, if you are going to solve, no, if you're going to perform calculation, your engineering ways of calculating the most economic section, ang magawas ana sa may circle gyud daw. Pero dili siya ga-adapt because it is very lisod to construct. Okay? So imagine na lang nimo, unsaon lugar pagbuhat og porma didto sa site nga ang gawas nga channel is sa may circle. No, this does not include the kuan ha, the reinforced concrete pipe culvert. Lahi itong culvert that is flow in pipes already. We are just limited to the channel. So if you are going to construct a channel, for example, sa kilid sa dalan, unsaon lugar nimo pagporma ang semicircle? Although it is possible, but it is very hard and it's not practical to construct a semicircle channel. So that's why dili gyud siya ginapili always. Okay, so let us proceed. So the previous equation can be rearranged into this one, still Manning's equation. Okay, if you are trying to solve for the area. Okay. So sa una, sa hydraulics, we were ay amot lang ha, pero sa amo it was the case. I don't know with your case, we were asked to solve for the proportioning of the dimensions of each of the hydraulic section. But this time, we are no longer going to perform that one. Okay? So we are just going to base our judgment, no, in the best hydraulic section or the best geometry on this table 5.1 given by the book of Chen. Ay, Chin ba to? Chen ba to? Chin rather, Chin. On water resources engineering. So, for example, if you want to have a trapezoidal form of channel, then the best section for that is for you to have a half of a hexagon. Okay, and your area will now be this one, your wetted perimeter this one, and the total top width of your channel will be equal to that one. So same goes with your rectangle, your half square, and um, these are the proportions of your area, wetted perimeter, and the top width. And also, if you want to have a triangle, then the best geometry for you to adapt, no, so that you're able to bring out the best hydraulic section is for you to have half a square. No, ironic kayo, triangle pero half a square. Pero for you to have the most efficient triangular channel, you have to have a half a square. So that means to say, in your triangular channel now, okay, the angle of inclination from the horizontal sa kaning side sa imong triangle shall be 45 degrees on both sides. So since this is 45, 45, this is 90. So this is half a square. So kung imo na siyang i-project to 90 pud na diha. So that means to say, although you did have um at a triangle, but if you're going to consider the angles, it is actually half a square. Okay. So mo to siya, and the proportioning for the area, the weighted perimeter, and the total top width will be this one. Okay? And the semicircle and the parabola also. Okay? So ready-made na ni siya. Okay. So the most efficient shape of all best hydraulic suction is the semicircle man gyud. However, the shape is not practical to construct. So the semicircle shape can be approximated. Okay, we can have an alternative for it by using a compound section that is composed of a lower trapezoidal section and an upper rectangular section. So if you really want to have a semicircle na channel, no, so gusto jud lugar ka, for example, ana, no? Okay, that's not a semicircle. That's okay. Let's not automate na lang. Okay, ano na lang. So, for example, this is a semicircle, no? So, instead of having it a semicircle, for easier constructionability, no? For you to have an easy way to construct your channel, you're not going to have really the exact shape of a semicircle. Instead, you're going to have half trapezoid to mimic the um, curved bottom part of the semicircle, and then you're going to add na dayon the vertical sides, which is actually which can be considered as a rectangle. So this one, the upper part is rectangular and the bottom part is trapezoidal. So, kung gusto gid mo siya i-push nga dapat gid siya semicircle or duol-duol sa semicircle. Okay, that is how you are going to do it. Okay. So although the best sama sa hangingon ganihan, no. So although the best hydraulic section appears to be the most economical in terms of excavation and channel lining, it is also important to note that this section might not always be the most economical section for one or more of the following reasons. First, the flow area does not include freeboard, and therefore it is not the total area to be excavated pa. Also, it may not be possible to excavate a stable best hydraulic section in the native soil. That means to say, the characteristics of the native soil or the existing soil, kung asa nimo i-construct dagto ang imuhang channel, okay? Magdepende po diha no kung unsang section ang imong i-adapt. For example, when you found out that the native soil is weak soil, so that means to say you have to provide a channel that is more stable. So on the other hand, if you find out that your native soil is of good quality, meaning to say strong siya, no? Strong soil. So that means to say you can have um, the not so stable nga mga hydraulic section. Okay? Also, the depth of the channel might be limited due to high water table or underlying bedrock. So the hydraulic section must or might cause unstable flow condition also. No? If the flow is near critical. So, for line channels, the cost of lining may be comparable to the excavation cost. So, cost of lining shall also be considered. Okay. Large channel widths and mild slopes will result in high costs of right-of-way structures such as bridges. Okay, mild slope. Kana itong lapad kayo. For example, kana we have a steep slope for the trapezoidal. Napoy kana bitong ana kayo. Mild slope lang siya din eh. So, although tsada na siya, no? Pero dili siya good choice if the yuta that you are going to where you are going to construct your channel is paliton pa, meaning private lots. So mas dako man ang land area nga makonsume ani compare ani. So this choice might not be the most efficient one. Okay? And also, the ease of access to the site and the cost of disposing of removed material may also affect the economics of the channel design. Okay. Ayan. Okay, so we will read this one. So let us have a very simple sample problem here. Okay, so if I'll just zoom in a little. Okay, so we have here example 5.1 in the book. A triangular concrete lined drainage channel is to be designed on a slope of 0.5% and accommodate a peak runoff rate of 0.15 cubic meters per second. Determine the optimal dimensions of the channel. Assume n is equal to 0.013 for the concrete lining. Okay, so din ni ang case, na-identify na nato nga we want a triangular channel. Now the challenge for us is to get the dimension, to get the sukud, or how big, how huge, or how small will our triangular channel be. Okay? So let us solve that one. Okay, let us use black pen. Okay. So let us have the given information. First is we have the section. So the section is given to be triangle. Second is the peak runoff is also given, which is equal to pila? 0.15. What else is given? We have the slope, 0.15%. For approximately this is, ay, point 5 pa lang. 0.5. 0.5% or approximately this is 0.005. What else is given? N is also given, which is equivalent to 0.013. What else? Okay, mao lang. Okay. So now let us solve for. Okay, so if I'm going to draw here na lang sa. Okay. So for example, this is our koan channel. Now we have already identified it to be triangular. Okay. So, mo kibali na siya. This is the, maklaro ba? Oops, maklaro. Okay, this is the tubig. Now, we already know nga, triangle gud siya. Pero we have to identify now, yung dimension, ma'am ning gipangita sa tuang. The dimension of the triangle is this one. So, this is the y, right? And also, if we are going to name the sides S na lang siguro, ay naman tayo SDI. So, let us just give this A. So, we have to identify this one. And also, the degree of inclination diri, pila ang theta diri. Okay. So, let us solve. Let us have Manning's equation. Manning's equation says that Q is equal to, ano ito? 1 over N ARS 1 over N area R 2/3 S 1/2. Okay. So now we have the value for our N, which is equal to 0.13. Area, is it, do we have the value for our area? Do we? Anyone? Naa ba wala? Yes or no? Bobadilla, Mark Anthony. Do we already know? Okay, that's very good. We don't have the value for our area. Now the R is, okay, R is equal to the area over the wetted perimeter. Okay, we don't have the area. We also do not have the wetted perimeter because both of these values would include dimensions of our triangular channel. Now the S is also known. We have the value for it, which is equivalent to 0.005. Now, since we are trying to identify the best hydraulic section, let us take a look at this table here. Okay. So, na based sa problem, our channel is to be composed or to be made up of or to be made as a triangle. So, now the best geometry for that is to have it as half of a square. Okay. Now, the area will be this one and the wetted perimeter will be this one. So, since naman nga table, then we will just automatically use this one. So, therefore, area will be equal, okay, area will be equal to y squared. The wetted perimeter will be equal to 2 the square root of 2y. Okay. So, transforming Manning's equation, this will become Q is equal to 1 over N A. Okay. So, instead of writing R, we are going to use A and P. Okay. A over P raised to the power of 2/3 S raised to the power of 1. So to simplify this one, this will become 1 over N. The area here will now have the exponent of 5/3. That is 3 over 3 times 2 over 3. So then the P, 5/3 rather, 5/3. Area is 5/3. Dian P, 2/3. S raised to the power of 1/2. Now, let us substitute the given value. So, Q is equal to 0.15, 1 over 0.013 times the area, which is y squared. Not this one. Area is y squared raised to the power of 5/3 over P, which is 2 the square root of 2y raised to the power of 2/3 times the S, which is 0.005 raised to the power of 1/2. Okay. So from this equation, we only have the y unknown. So can somebody solve for that? How much is y? Okay, it is uh, point 32. 0.32 meters. Okay, that means to say this y is equal to 0.32. Okay, so now you only have one known, no, in a triangle, and we know that when you are dealing triangle, you need at least two known values to proceed with your calculation. So now we need the angle in this case. Okay, and or we can have the value for the sides, but we cannot solve for the value of the sides if we do not have the angle. Now, based again sa table, your triangle should be half a square, and as I have mentioned kaganiha, if it is half the square, the angle of inclination will be 45 degrees. Okay, so from that, if you want to identify, no, for example, you want to um you want to concrete pour for this lining, no, you want to have concrete as your lining material for this side and also for this side, so you need to get the exact dimension of that. So how are you going to get that? How do you get the value of a? Since this is 45 degrees, you can cut this and make a right triangle here. So since this is 0.32, if this is 45, this is also 45. Okay. So now you can proceed using Pythagorean theorem in solving the sides or the dimension of the sides of the triangular channel. So ana lang siya. Do you have any questions so far? Wala? Okay. Can I get a heart react if you do not have questions? Okay. Okay, so I think majority of the class do not have questions. I will now exit my presentation. Okay, so that ends our discussion for tonight. I will now be checking your attendance. You are for Ayman Mono. Okay. Abaw.
Present, ma'am.
Abonatilia, Baguio Erica,
Present, ma'am.
Bobadilla Mark,
Present, ma'am.
Cabana Angeli, Kabilaw Joshua,
Present, ma'am.
Kahintong John Louie,
Present, ma'am.
Kalagsing Kent, Kalipayan Nathaniel, Cantero Joe, Dalis Don Francis, De Los Santos Sebastian,
Present, ma'am.
Deloso Desiree,
Present, ma'am. Good evening.
good evening, Danlasa Dea,
Present, ma'am. Good evening.
Dumanag J. Boy,
Present, ma'am.
Dorano Elmer, okay, Lanzadera Sara, Laroga Josephine,
Present, ma'am. Good evening.
good evening, Vocero Rica,
Present, ma'am.
okay, Lungay Shania, Makula Raji, Mata Alexander,
Present, ma'am.
Murdas Naji,
Present, ma'am. Good evening.
good evening, Nesperos Paul Vance,
Present,
Nespe-
ma'am.
okay, Ranieses Jovi, Ranieses Jovi, Ribalde Junreal,
Present, ma'am.
Sultan Noraisa,
Present, ma'am.
Tagod Esel, Tambis Jomar,
Present, ma'am.
Texon France,
Present, ma'am.
Chu Contreras,
Present, ma'am.
okay, Ranieses present. Uh, okay, Bonatilia present already. Cantera present.
Thank you, ma'am.
Kasi wala na tawag-tawag, bumitig ka, Ranieses Jovi, kapila pa. Kapila ta gitawag. Okay. I've called your name. Lanzaderas. Okay. Cho Contreras.
Present, ma'am.
Okay. Tokero Lovelin.
Present, ma'am.
Tuwal.
Present, ma'am.
Ukab Janet. Okay, present siya. Valyespin Kathleen.
Present, ma'am.
Velas Kathy. Okay. Villanueva Ren. Ibanez Kim Harold.
Present, ma'am.
Ibanez May.
Present, ma'am.
Zaya Cyrone. Yeah, present already. Okay, it's okay. It's okay, Jovi. Zaya Cyrone.
Si Zayas daw, ma'am, kay namatyan daw sila.
Oh, okay. I'm sorry to hear that. Okay, so I will just call those who were not marked present. Cabana Angeli. Kalagsing Kent.
Good evening, ma'am. Present si Kalagsing, ma'am.
Okay.
Thank you, ma'am.
Okay. Kalipaya Nathaniel. Dalis Don Francis. Lungay Shania.
Present po, ma'am. Good evening.
Makula Raji. Tagud SL. Villanueva Ren. Wala. Okay, so I think those names who were not called, kaganiha, on the second batch, you are already marked present in the attendance for this evening. So if you no longer have questions and clarifications, then that would be all. Yes, Bobadilla.
Good evening, ma'am. Regarding sa kadtong quiz 2 bitaw, ma'am, last week
Yeah.
ng imo tong i-consider among concerns, ma'am.
Yeah. Regarding question number 2, was it question number 2? In the problem
Quiz
solving?
2. Yes, ma'am, part 2.
Yeah. I will consider that one. I have solved manggod that one manually, and then I lost my papel ba. So I still have to solve it once again. And then your concern was dili siya makuha if English, tama ba?
Yes. Yes po.
Yeah, you have to use the metric. Sige lang, I will try to solve again, and then do not worry because I can just remove the point for that specific question, and that will not be included in the scoring system anymore. So that will serve as the bonus.
Okay, ma'am. Thank you.
Okay, you're welcome. So any more questions? Yes. Who is raising na? Naji.
Ma'am, kanang about atong quiz 1, ma'am, ba na wala ko ka-take? When ko pwede makatake, ma'am?
What was your reason gani for not
Kwan,
taking?
na katong na-dengue ko for 1 week.
Hmm. Okay. Sige, can you PM me on Saturday? So I
Okay.
can, because we will not have a quiz man
Okay, ma'am.
on Saturday, then you can take quiz one on Saturday. But I will give you a different questionnaire na.
Okay, what time, ma'am?
Um, it would be better if sa morning.
Morning?
I know I will be joining a seminar Monday on that day. Yeah, kindly just message me on the morning so that I will be able to read it siguro mga early afternoon. I will
Okay,
be
thank you,
reminded.
ma'am.
Okay. Any more questions and concerns? Okay, if wala na, then that would be all for tonight. Thank you so much for your time. The class is dismissed. You may now leave the meeting. Thank you.
Thank you, ma'am.
Thank you, ma'am. Goodbye, ma'am.